So as part of exceptions, let us start here. Now what I'm doing is I have a class exceptions demo and I created an object for demo and demo dot. Do you have any methods in this class in exceptions demo?
No.
No, right? But then when I click dot, I see some methods. Where am I getting these methods from?
Those are wrapper classes.
Wrapper class? Which one?
These methods,
Uh-huh.
which were default will be there in the
In
header
which class?
files.
In which class?
The wrapper class.
What do you mean by that? Wrapper means when we're discussing about primitive types and wrapper classes, meaning for int we have an integer, a class called integer.
Yeah.
But now I'm not talking about that, right? I don't have any int or integer here. What I did is
Okay.
I did a plain class exceptions demo, and actually you have the solution here. It is in a class called object. It's in a class called object. Okay, and if you look at this, see here, Java doc of the class object. You have the methods like, whatever you saw there when I right click, those methods are available here. See here, the methods. Okay, so here the logic is that every object by default it extends a class called object. That is implicit. It doesn't have regular inheritance. Let me see if I can do this. It doesn't work again. If I specify explicitly, it doesn't work. But there is an object called, there is a class called object. Object in the package called java.lang. Okay, so this object has, I'll remove the parent as well. I don't need it. Some of the common methods that's very often required. We may not be using at present, but we'll be using sometime later. Now, that object is implicitly extended by every other object that you create, every class that you create in Java. See, the object is java.lang.object is what it is the class or object. It is a class. Java.lang.object. Object is the class name such as. And every other class that you create in Java that implicitly extends this particular class. Okay, and it doesn't or regularly inheritance cannot support, you cannot extend multiple classes. But here, because this is so implicit that you don't specify explicitly, so it doesn't, that's how they designed Java. So it doesn't affect your regular inheritance. Now on top of this, java.lang package, if I look at java.lang package, usually like I don't need to specify the import statements. Java.lang package is imported implicitly. Again, if I write something called string msg equal to test, and where is my string? String class is into this package called java.lang.string. And am I importing the class in the Java, in this particular class, java.lang.string here in the Java? No, I'm not doing it. The reason is that it is imported by default. It is imported by default, right? So that's the reason you don't need to explicitly specify or import many of the commonly used classes. I mean the wrapper classes. If I look at, integer, java.lang.integer. Okay, so now suppose if there is any problem, generally, how do you handle errors? How do you handle errors in other languages other than in Java? Suppose if I want to do something like, int a equal to 100, int b equal to 0, okay, a divided by b. What will be the output here?
It's undefined, right?
Sorry?
It is undefined. Infinity, but it will not show the output.
It will not show the output, okay. Okay, Suji, you have any different answer?
No, sir. Infinity. We have to raise exception.
It will rise exception. Actually, 100 by 0 is an error condition. Infinity, there is no definition for infinity in programming language. You cannot understand or handle that kind of situation. So that is an error condition. Okay. And similarly, okay, there's something that we did not discuss during data types is the arrays. But I think you guys having some basic understanding about programming, so I think that's pretty much fine. Now int af equal to new int of say 5. What is it? Okay, I'm just declaring an array of int 5 size, and what I'll do is, what will happen now? What, what is the size
It will
of this
raise an
array?
exception.
Huh?
It's five.
It works fine?
No, the array size was 5 and we don't have an element called 10.
Right, so it will throw, I need to comment the first line in order to, so it throws something called array index out of bounds exception. Okay, so the brief introduction about exceptions is that Java way of handling error conditions. Okay, so it throws exceptions, and there are ways you can handle the exceptions. Suppose if you think that it is okay to have a by 0 as that divide by 0 exception, so what I can do is I can catch the exception. There is some, I introduce few additional keywords, so you need to follow me. What is this? Only divide by 0? And I don't see. How come? How come? Oops. This line also should be printed. Huh? Yeah, another important thing about using Eclipse is that debugging. I'll give you a brief stuff now, and tomorrow also I'll discuss about debugging. What you can do is, uh, oh sorry, I need to do system.println. No mistake, but stack trace is supposed to print it. If I do, instead of run as, you can do debug as Java application, okay, and you can put a breakpoint. See, there is a blue vertical line here. What you can do is, you can double click. When you double click in the empty area, what happens is you are putting a breakpoint there, meaning your program will halt there in the Eclipse. Okay, so I did the four breakpoints. So what I can do is debug as, see, now the program comes here and it stopped there, it paused a while there, and I can put my mouse here and see what is the value of A and the value of B. Okay, and next I can press F5 and F6. I'll press F6 for now. I'll say, see, there is an exception happened, and it went to the exception block and it printed divide by 0. Next it came to, I'm pressing F6 continuously. Now it went to the next line, and again there is an exception, and again that catch block, whatever is the printed message. Oops. Okay, I just printed simple line 10. That's okay. But why it's not really did not print AIE? This is interesting. IE dot print stack trace. This is supposed to print. Okay, yeah. Oh, I did something mistake then. Yeah. So I just wanted to show you the two different things. So at the outset, this is how if system generated exceptions, it is possible that you can handle them. Say if you think that that is okay for you in your logic and you want to still continue, then what you need to do is you can do try catch. Otherwise, if you don't do try catch, what happens is, say suppose if now see the line when A by B is there here, and program will exit from there when there is no exception handling. Now further next lines will not be executed. That is the reason. That is the reason you did not get this output. This line will never be printed. It's not printed in the console. The reason is that if you don't handle exceptions, it will control will go back to the caller. Caller means suppose if this happens in a particular class and some other class is calling some other class, some method is calling this particular method, then the exception will go back to the caller, and that in turn will there will be nested. If I have say three classes, now maybe I'll create another. In simplest scenario, I'm trying to do this. Okay, I'm just doing very dumb logic there, nothing much. I don't have any variables, hard coded the values. Now what I will do is create an object for now what will happen is that the simple exception is the class simple exceptions class generate exception method is going to print, sorry, throw an exception. Now if you look at this line, if you look at the exceptions track trace, means like it will show you where the exception is happening and why. You look at this first top level exceptions demo.java 14, line number 14. It is calling first sc.generate exception, right? And this sc.generate exception is actually like into simple exceptions.java. I'm just clicking this link, see here. I'm just clicking the link and then it is taking me there. Okay, so what is happening is that when I call, what I'm doing is in the exceptions demo, I created an object for simple exceptions class SCA and calling this method. So exceptions demo class is the caller for this particular method, right? So when I call this method, if there is an exception, the exception is given to the caller. So that is the reason I'm actually seeing a line here. Okay. Now other way, I mean, if you want to, so sometimes it happens that you leave the exceptions to the caller. I don't want to handle anything and I leave it to the caller. Now other way is that I do a try catch here. I can actually do print stack trace. Now what happens is that the exception is raised in this line and it is thrown, exception is thrown, but you are catching the exception and handling it. I'm managing the exception, the error condition. So caller will not have any idea about the exception being raised. But because I'm putting, ae.print stack trace, it will print the, I need to run. It will print exceptions demo. I do have the cast statement, right? Why is it printing the stack trace? Okay. Yeah, I'm asking it to print the stack trace. But then if you notice it, earlier only this was printed. Now because I'm doing a try catch, okay, so the and in the catch I'm printing this complete line exceptions track trace. Track trace means complete flow of exceptions. Who called this method and what line this exception has happened at which class. So the complete flow is there available in the stack trace. And when you do exception dot print stack trace, meaning exception object dot print stack trace, then it will print that complete structure. And if you are using Java frameworks like Spring Framework, any simple exception, simple error can actually throw stack trace of pages and pages. It will be very big. It depends on how complex is your flow. But for now, this is sufficient. Now, because I am handling this exception here, and it's able to go to next line, and I'm printing, here again you are doing a dot a by b, that's 100 by 0. So here what I'm doing is system dot air dot println. System dot out dot println will print like a normal text. But when I do system dot air dot println, this prints that in a red color. This output will be in the red color. Okay, that is the only reason. Otherwise, it's pretty much, if I change it, it will become like, your black text. See here, divide by 0, by 0. And printing on the console is sometimes it doesn't follow the order. It doesn't really follow the order that you, sometimes it comes when I do, error actually took precedence. But when I make this as out and run this, see, divided by 0 line is coming at the end. Now let me run this again. See, it came somewhere here. So when I actually use the out, system.out and system.er, both of them are printing related objects only to print on the console, but error takes precedence. Error object takes precedence, so whatever is there by that, it will be printed first. Then I think it will be like multiple threads. So threads we did not discuss, but we will discuss going forward. But I just want to show that the output is a bit different when I use. It is coming properly only. Execution handle is proper, but only thing is the particular way the output appears in the console. When I use this thing, I cannot guarantee where this is getting printed. Sometimes above, sometimes below, right? Fine. This is about the basic stuff about exceptions. Meaning exceptions, Java has exceptions, and we do, when at error conditions you do them, you actually try, you put try catch block. If I have 100 lines, also say whatever exceptions are possible, what you do is you put them, all the lines of code, into here and put into a try block. Okay, so and then you follow a catch block. Okay, so this is the basic stuff. And what I'll do is now let's actually look at the classes called this exceptions classes. Now if I look at arithmetic exception, that is into java.lang.package. Okay, and this exception extends another class called, hope you understand this because we already discussed about inheritance. You understand the keyword called extends. So this code I have enabled decompiler, so that is the reason I see the source code of the exceptions. Otherwise you may not see them. Now I clicked F3 on this exception, runtime exception, and runtime exception again has some code into the class, and then it extends something called exceptions. And exception class, if I go to exception class, then I see some definition for this class, and then it says extends throwable. Throwable is another class. Now in the throwable class you have some stuff. In fact, the print stack trace method is pretty much is available in the throwable class. In the throwable class, so many other methods as well. And system not okay, fine. So these methods are available into throwable class. If you notice in the Eclipse, that what I'm saying is the decompilation part, and that is because I don't have the source code. Rather, it says throwable.class in the top. Look at the header here in the tab. And similarly for exception, similarly for random exception, arithmetic exception. Now, so that actually means that in Java, the exceptions are actually, the basic exceptions are available. The package is called java.lang only. In the base package itself, I have a class called throwable. Now, in our particular context of arithmetic exception, now throwable is there. Exception, a class called exception extends the throwable, right? And then there is something called random exception that in turn extends exception. And finally, the class arithmetic exception extends random exception. So this is the flow of hierarchy for arithmetic exception. But now I want to show you that how this hierarchy looks like. Now here is a standard, this list is not complete. There will be other exceptions as well, but this particular diagram gives you the exceptions hierarchy at the outset. What is the base class of all the Java classes in Java? What is the base class? Chikant?
Object.
Sorry? Sorry, can you come?
Object.
Object, yes. So, Srikant, you there?
Yeah, I'm
Okay,
there.
right. So object is the base class, and in case of exception handling, next is a class called throwable. Okay, there is a class called throwable, and then you have it has one derived class called exception, and exception has various different type of classes here, different type of exceptions, as well as these are the child classes. Okay, if you look at exception, then you look at class not found exception. Class not found exception is a child class of exception. Similarly, class not supported exception is a child class of exception. And interrupted exception, no such method exception. So these exceptions are child classes of exception. And also we have when the interesting thing for us is random exception at present. So random exception is also a child class of exception. Okay, and now random exception class has different child classes. If you notice here, arithmetic exception, array store exception, class cast exception, illegal argument exception, illegal monitor state exception, index out of bounds exception, negative array size exception, null pointer exception, security exception. Now, if you look at index out of bounds exception, we actually particularly got array index out of bounds exception. Similarly, number format exception for illegal argument. So, there is a hierarchy of classes in Java. There is a hierarchy of classes in Java. Okay. So, is this clear about the hierarchy? You don't really need to mark everything, and slowly as you use, you will try to remember these classes. Some of the classes you will remember by default without any problem. And for some of them, if you don't use them, no problem if you don't remember also. But then as and when you need to, but what you really need to understand is that exception hierarchy. The base class is called object, and then throwable actually, like base class for all the Java objects is called object, right? Now in case of exception handling, in case of exception framework, the base class, immediate base class is called throwable, because object is implicit, but explicitly throwable is the base class in the exception hierarchy. And then goes exception class, and that exception class has child classes, and also it has one child class called runtime exception. Okay, now I'll close this or this particular stuff. So there are multiple ways of how you handle exceptions. Okay, so suppose if I don't want to handle exception in this particular method, simple exception, okay, and I think the best way is I need to explain you something called void generate. I want some example for, okay, some generate checked exception. Okay, equal to new file. Oops. Exactly. Now, don't worry about these lines for now, but what I want to show is that there is something called, there are certain exceptions there, in case of 100 by 0. Let me do this. In case of 100 by 0, I don't see any error such as, okay, I don't see any error, but when I run, system throws exception. But when I write the code, it will not alert me that, okay, there is an exception. But there is a different type of exceptions. If I look at this particular class, it throws an error. It throws an error stating that unhandled exception type file not found. Okay. Either I need to add, try catch. Look at this. Now that this is handled, I do a try catch and I'm handling this. This we know that we can handle exceptions like this. But I'll introduce you to another keyword called add throws block. Now see what happened is that there is an extra syntax. Try catch is different. Try catch means you're trying for that code that whether any exception is possible. Okay, and when there is an exception, you are handling a catch block. Okay, and if I don't want to do this, if I don't want to handle the exception myself and I want to give it to the caller, then I can do this. Then I can do this. What I can do? Throws block. I can use a keyword called throws. Okay, so throws is to throw the exception to the caller, and try is to actually to try the code, whether there is exception or possible or not. Catch is to say whether you want to handle the exception or not. If you put a catch block, that means you are assuming the exception. Okay, but now what I was actually telling was that there are two different scenarios. And let me remove this. Now I have two different scenarios, and c equal to 100 by 0, this throws exception, and file input stream file stream equal to new file input stream file, this also throws exception. But my compiler is throwing exception or error only in one case. See, here it is throwing an error saying that unhandled exception. But why is that it is not throwing? Why is that it is not throwing exception in this line, or it is not throwing any error, compilation error in this line? You have any answer for it? See, exceptions are basically two different types. What we call them is, one is checked exceptions and other one is called unchecked exceptions. Checked exceptions means that compiler checks if that exception is possible. Okay, compiler already checks, during compilation it checks whether this exception is possible or not. If there is a possibility for any type of exception, then you need to explicitly handle it. You need to explicitly handle it, and if you don't handle it, you will get an exception like, you will get a compilation error like this. Unhandled exception type file not found. Okay, file not found, and this is called checked exception. Checked exceptions are the exceptions that are derived from, sorry, not this particular thing. What I'll do is add try catch, and then now let's look at this. Now if I look at the file not found exception, that extends IO exception, and IO exception extends exception class, right? So there is a mild difference between this flow and the other flow. If I look at arithmetic exception extends runtime exception, that in turn extends exception. One extra class is that runtime exceptions, see, all the classes that extend, all the exceptions that extend from a class called runtime exception are escaping or escaped, they will escape from compile time exceptions, or compiler will not validate whether that kind of exception is possible in the code or not. It will not show any compilation error. Rather at runtime, the exception is possible and you need to handle accordingly. So there are two different type of exceptions, checked exceptions and unchecked exceptions, or unchecked exceptions, other name is called runtime exceptions as well. So runtime exceptions or unchecked exceptions basically are the exceptions that extend from a class called runtime exception. Otherwise your regular class, your regular other exceptions, like in this case file not found exception, actually comes from IO exception, and IO exception in turn comes from exception class. So whatever is a derivative of plain exception class, compiler checks whether that kind of exception is possible in the line or not. Okay, and if it is possible, it will throw you error. It will throw you error that you need to handle this exception explicitly. So that is the magic that was happening when I do this. See here, handle exception of type file not found, because file not found does not come through runtime exception. It comes from exception class directly. It has a parent class that in turn called IO exception, that in turn extends from exception class, but there is no runtime exception in the middle. That is the reason you need to mandatorily explicitly handle it. So that is the difference between a checked exception and unchecked exception. Checked exceptions are the ones that compiler validates whether exception is possible or not and throws an error. In case of runtime exceptions or unchecked exceptions, compiler will not throw any error. So it is clear so far. I try to introduce you to exception hierarchy and different type of exceptions. And why exceptions and what exceptions? You know, how do you or where do you use exceptions? Is this clear so far?
Yep.
Okay, sure, right, Suji?
Yes,
Yeah.
yes, sir.
Yeah. Okay, perfect. Because it's been, more like I've been talking, and so there are a few more keywords and exceptions and some other interesting stuff. So other keywords is that when an exception happens, what can happen is that uh, the next set of lines will not be executed. Next set of lines will not be executed. Where am I? Okay, I'm here. If I do this, this line never gets printed. And when I run this, and for runtime exception we have already seen. So what I will do is try the catch. See, when you're catching, I'll explain that, even if I put exception, it will work. Because exception being the super class, it matches any exception that happens. I'll explain, how to use this logic. But for now, my flow is that what I'm doing is I'm calling generate exception, or maybe this one is, I'll change the name. I'll change this name to generate runtime exception. Okay. Now, so here I'm calling generate runtime exception and generate checked exception. There are two different methods. So basically that you get the output, but if I see from this particular thing, whatever lines or logic that you write after, exception happens at this particular line. Okay, exception happens at this particular line in this case because there is no file called test.txt. So it throws an exception, file not found exception. It must be, see here, file not found exception. Test.txt, the system cannot find the file specified. Okay, and before that we called generate runtime exception. So that has divide by zero arithmetic exception. So when this particular exception happens, now I'm focused only on this line. I focus only on the file input stream, file stream equal to new file input stream, or maybe, just to be input stream. Okay, it doesn't really matter. I just want to mark that, that is a and variable name is file input stream itself. Okay, now this line is not printed at all in the console. The reason is that an exception happened, error happened at this line. Okay, when an exception is raised at a particular line of Java code, then subsequent catch block gets invoked, and the lines before that will not be executed at all. Okay, so now what if I want to run certain lines of code? See, this line will never be called. This line will never be called when there is an exception. Now, I want to make sure that I want to print certain lines. I want to print certain lines, or I want to execute certain lines irrespective of whether there is an exception or not. Whether there is an exception or not, I want to print certain values, or I want to execute some logic basically. Okay, so how can I do that? So then comes another thing called finally. Finally, this gets printed irrespective of exception or not. See here, this gets printed irrespective of exception or not. There was indeed an exception, but then this line is not printed. Next line, and never gets executed because exception is raised before this line. So when there is an exception that happens, the next subsequent lines, whatever are there, they will not be executed at all. So what I can do is, I can write a finally block, and execute my code. Within the finally, I can write my logic. Whatever logic you write, that gets executed. That gets executed. Okay. So that's something that I wanted to introduce you to. Exceptions, so the keywords that we have seen so far is try, catch, finally, and what is another one? There is one more keyword that we have seen called throws. It is called throws. Suppose if I want to here, if I want to throw the runtime exception now, throws arithmetic exception. So actually, like in this case, in case of random exceptions, I don't need to specify this, but suppose what I can do is, in this case, I'll put one more. I'll just copy paste this method. I'll just copy paste this method and say with throws. Okay. So what I will do is that oops, I'll remove the try catch. Now in this case, okay, I wrote the same method again. I removed the try catch and say add throws declaration. Okay, so when I say throws, we have seen this already. When you use this keyword called throws, what happens is that when there is an exception called exception, especially this is for checked exceptions, compile time exceptions, where compiler can throw exception related error. So in that case, if you want to get rid of that error, or if you don't want to handle the exception within your class, within your logic, then what we do is, why is this lines? Yes. Okay. Now I just formatted this code, Control Shift F. So what I want to do is, I don't want to handle this exception. Rather, I want to give it to my caller. Whoever is going to call me, that guy, let him handle this exception. So how that happens is, I wrote sc.generate checked exception. Now see here. Now because that exception, whatever exception that is possible here, the file not found exception, because it is not from runtime exception, so it is a compile time exception or checked exception. So that is the reason when I use throws keyword here, the error from this place is it disappears. Okay, but now the exception goes to the caller. Who is the caller? Exceptions demo is the class that's a that is a caller. That is where you are calling this exception. So here it shows that unhandled exception type file not found. Now it says that it is possible. That this line throws an exception. Okay, fine. So again, how can we handle? There are two ways. One is either you add throws block again, but when I do throws block within the main class, or class having main method, it doesn't make much sense because it goes to the JVM and your program will halt anyway. So what I can do is, other alternative is surround with try catch. Surround with try catch and you handle the exception. Okay, so So far what we discussed is that the need of exceptions are primarily exceptions is the Java framework to handle error conditions, and within exceptions we have two different type of exceptions: checked exceptions and unchecked exceptions. Checked exceptions are the ones that are extended, that are created by extending a base class called exception. Okay. And because of this checked exception nature is that the compiler will know that if you write some logic, and within the logic at a particular line, if some sort of exception is possible, then compiler will throw you an error that you have to either handle using a try catch or use a throws block so that it goes to the caller. Okay, that's about exception flow. One sec. And okay, and other keyword that we looked at is that in case of a runtime exception, the exceptions are compiler will not really care for those exceptions. It will not check whether the exception is possible or not. It is only that at the runtime, meaning when you run your application, that is when runtime. So during the actual execution, if exception is possible, that will happen. So in case of runtime exceptions, if you know that some sort of exception is possible, then it is better that you handle that exception so that there will not be any surprises. Okay, and then if you don't handle, your program will exit. Okay, so for runtime exceptions, compiler will not throw any exception or any error, whereas compile time or checked exceptions, compiler will always throw errors if exceptions are possible in the code. Okay, and now we also looked at try catch is for try block is uh, for putting certain lines of code to verify whether an exception can occur or not. Okay, to try for the exception. Catch is to say, okay, fine, I want to catch this exception and handle it on my own way. When some kind of error happens, what you do generally, you tend to address that error, right? So catch is for addressing the exception conditions. Now throws is say that if I don't want to have any logic in my class, if there is exception happens, then I don't care about it, rather I pass it on to my caller. So that is when you use something called throws keyword. Okay, these are the things for today. What I will and also look at this hierarchy. Look at this hierarchy. So the exceptions are basically they start from object and throwable and exception. Whatever classes that are directly in the from exception class, they are called checked exceptions. Compiler will always throw that kind of exception. If exception is possible, throw an error. Whereas runtime exceptions are dynamic. So you don't expect, you don't expect compiler to figure out whether exception is possible or not. So any child classes of runtime exceptions are runtime exceptions only, or unchecked exceptions. Unchecked exceptions. So any derivative classes from runtime exception are called runtime exceptions or unchecked exceptions. Do you understand the difference between these two, checked exceptions and unchecked exceptions?
Yep.
Yeah. So and the keywords called try, catch, finally, and throws.
Throw.
Okay. So we have one more thing. We have we can pretty much throw exceptions. We can raise exceptions. Now what I can do is sometimes we do need to raise exceptions. Now what I can do is that I can comment this line. Okay, and I can say throw new arithmetic exception. I say that I'm I mean just message again custom arithmetic exception myself. Okay, it is possible that you can raise the exception on your own. It is possible that you can raise the exception on your own. This is how we do it. Instead of this line, I do this. The output will be earlier. I mean, you can see this. Let me run this. Not this, but see. I am throwing the arithmetic exception myself. See here, this line. Okay, so it is possible that you throw the exceptions manually, and this is another keyword. So far, these are the things, and about exceptions, and it is so the keyword that we tried is try, catch, throw, throws, finally. Okay, so these are the keywords related with exceptions. And I'll actually, like, what we will do tomorrow is that we will try to create custom exceptions. We will try to look at what is a custom exception, and how you create custom exceptions, and why do we need custom exceptions.